This phenomenon applies to any closed loop, not necessarily circular. For example, suppose a beam of light is split by a half-silvered mirror into two beams, and those beams are directed in a square path around a set of mirrors in opposite directions as shown below. Just as in the case of the circular loop, if the apparatus is unaccelerated, the two beams will travel equal distances around the loop, and arrive at the detector simultaneously and in phase. However, if the entire device, including source and detector, is rotating, the beam traveling around the loop in the direction of rotation will have farther to go than the beam traveling counter to the direction of rotation, because during the period of travel the mirrors and detector will all move, slightly, toward the counter-rotating beam and away from the co-rotating beam. Consequently, the beams will reach the detector at slightly different times, and slightly out of phase, producing optical interference fringes that can be observed and measured. Michelson had proposed constructing such a device in 1904, but did not pursue it at the time, since he realized it would show only the absolute rotation of the device. The effect was first demonstrated in 1911 by Hares, unwittingly, and in 1913 by Georges Sagnac, who published two brief notes in the Comptes Rendus describing his apparatus and summarizing the results. He wrote, "The result of measurements shows that, in ambient space, the light is propagated with a speed v0, independent of the overall movement of the source of light O and optical system.